Hello, today we are going to be looking at the topic of oxidation degree. This is a very important topic in order to further understand how redox reactions are equalized. In this regard, we will be looking at two methods of equilibration, which are the electron balance method and the electron-ion balance method. But to approach this topic, we will need to recall how the oxidation degree is calculated. Oxidation degree is sometimes also called the oxidation state degree. First, let's remind you that there is a concept of valence, but valency is a concept that is denoted by the Roman numerals 1, 2, and so on. There is a valency that can be constant and can be variable. The valency ranges from 1 and up to a maximum of 8. However, the concept of valence is not always convenient for working with reaction equations, especially with redox reactions. Therefore, the concept of oxidation degree was introduced, which is important to understand in connection with this term. The degree of oxidation can take three kinds of values. It can be 0, that is, it can have a charge of 0, it can be with a minus sign, and it can be with a plus sign. Let's start with the 0 state. All simple substances and elements have a 0 state. For example, it could be a hydrogen molecule. The oxidation degree charge is written on the right side from the top and is written strictly in Arabic numerals. We do not show the valency in this case. Next, for example, it could be the metal aluminium with a charge of 0. Crystalline sulfur, for example, can contain sulfur that is not connected to anything else and has a charge of 0. Simple substances with 0 charge remain neutral if they are not connected. However, in compounds involving nonmetals, the value can become negative. Thus, negative charges are only present when elements are combined. In their compounds are nonmetals. For example, chlorine will have an oxidation degree of minus. The unit may be written down, but we usually do not show the unit, nor the quotient, nor the index, nor the upper index including. For example, oxygen has an oxidation degree of minus 2, and let's say nitrogen has an oxidation degree of minus 3. But please note, only nonmetals can have such an oxidation degree. Now, nonmetals can also have positive oxidation states, but when they are in compounds with other nonmetals stronger than them, for example, sulfur may have an oxidation degree of plus 6, or let's say phosphorus may have an oxidation degree of plus 5. But it can also be positive in metals. For example, it can be aluminium in compounds. Let's say aluminium plus 3, or let's say calcium plus 2. Then it's a very important point to know the limits of where the oxidation degree is. So the smallest oxidation degree might be minus 4. Then it moves up to 0, for example. It can move, and it can move up to a maximum of plus 8. Below minus 4 or above plus 8, the oxidation degree cannot have a value. This is very important to remember because when you calculate the degree of oxidation, it's very important to keep this in check and realize that these are the limits. And so if you sometimes make an arithmetic error and you get, for example, a charge, suppose there is a mistake in the calculation where they erroneously add 10 instead of the maximum of 8. Occasionally, they claim to have a negative value of 5 in the calculation. This is simply not possible, as the lowest oxidation degree is negative 4. Let's explore the periodic system and investigate the patterns among the elements to accurately calculate the oxidation degrees. There are several rules that we can ascertain from this analysis that are important to remember. So, rule 1, we've already talked about it. Simple substances have zero charges, but again, for example, it's not just O2, let's say, or ozone, O3. But for example, when we talk about the compound nitric acid, when we put the degree of oxidation in this compound, we'll notice that when we put the degree of oxidation in this compound, we'll calculate the degree of oxidation in this compound. And we calculate it. All the charges add up. The sum of the charges in a molecule must be zero as well, implying that not only individual elements and simple substances have no charge, but the collective charge in the molecule as a whole must also be neutral. Now, the second point, there are some elements in groups that have a strictly constant oxidation state, like the elements of the first A group. Or that group number 1, it always has an oxidation state of +1, like sodium +1. Lithium +1. Next, the elements of the second A group or group number 2, they will always have an oxidation degree of +2, for example. In this regard, it could be, let's say, calcium +2, or for example, magnesium with a +2 charge. Next, the group 3 elements, or it's the third group A or the 13th group, which includes the element aluminium, oxidation degree +3. That's exactly what aluminium is most often found. In this case, it has a charge of +3. Now, the strictly constant oxidation degree is fluorine. Fluorine has a negative oxidation degree, always equal to -1, and it has no other except naturally 0 when it is a simple substance such as oxygen. Oxygen usually has an oxidation state of -2 in its compounds, but there are exceptions that are possible for oxygen, for example, in a compound like hydrogen peroxide. Hydrogen peroxide oxygen has an oxidation state of -1. For example, the compound O has fluorine 2, where the second is -1, and then oxygen has +2. Such a compound is called oxygen fluoride. In addition, hydrogen usually exhibits an oxidation degree of +1. For example, it exists in water or hydrogen peroxide, but it has an exception when it is bonded to metals. For example, in a compound such as sodium hydride. It would be -1 and sodium itself would be +1. And I'd like to make it clear that sometimes when we're working with oxidation states and ions, for example, if we're talking about aluminum, when it's an ion, its degree charge, the charge of its ion is 3+. And look, please, I've written that charge numerically, just like that. First a number, then a sign, it's an ion. But if I wanted to comment on its oxidation state, which is what we've just been studying, then the oxidation degree is written in reverse order, first plus and then 3. That is, there is a slight difference in writing what you want to comment on. It will be the charge of the ion, it will be the charge of the oxidation degree. But I explained that the charge in this case mathematically will of course be the same. 3 plus or +3 is still essentially a number with a positive value of 3. And so for ions, which are ions consisting of one particle, and if for example this ion has a complex structure, then respectively some. And so in the examples that we have analyzed today, we explained what the oxidation degree is and how it should be handled when working according to certain rules. But how to calculate it in specific examples, We will learn in the next lesson. I invite you to this lesson. But for today, goodbye.